Hey guys, simplifying and evaluating expressions right now. This is going to be a little bit more challenging because we don't have our calculators from school. So I'm going to help you figure out how to do that with our cell phone calculators. Hopefully you have one of those. If not, and you have access to the internet, obviously, if you're watching this, you could probably just type in scientific calculator. You might even be able to find a better one than your phone's calculator, but I'm going to be lazy and I'm just going to use my phone because we're going to be able to do it. It's just going to be a little bit trickier. For simplifying and evaluating expressions, there's quite a bit that I have to talk about. Talking about PEMDAS, that's your please excuse my dear Aunt Sally, aka your order of operations, the math term for it. So PEMDAS starts with parentheses, or in our case that you're going to see a lot of absolute values. Absolute value, do you see that little bar, those two bars that I have? So instead of a curved parenthesis, absolute value has those like longer lines. Okay, and absolute value is the distance a number is from 0. So your answers are always going to be positive because distance is always positive. So for example, the absolute value of 3 is 3. Same with the absolute value of -3. It's 3. You still have to count 3 over. After parentheses or absolute value, you have to deal with your exponents. And then multiplication and division from left to right. Addition and subtraction left to right. Another thing that this topic you're going to see, exponent rules. So for your exponent rules, you have to remember that when you multiply numbers with the same base, you add your exponents. So let me just show you real quick. So that's like saying x to the second times y times x to the third. You keep the base, which is x. X is the big number, or the base is the big number, and you add your exponents. So 2 plus 3 is 5. All right. The next one is dividing. So if you're dividing with the same base, you're subtracting your exponents. So if you have x to the 6th over x to the 3rd, you're subtracting. You keep the base, which is x, subtract your exponents. 6 minus 3, 3. Do not divide those exponents. You're subtracting. For power to a power, let's see if I could move this up. I knew that was going to happen. I can move it up this way. Yeah. So power to a power is like x to the 3rd power all to the 4th power. When the exponents are right next to each other, you would multiply. So 3 times 4 is 12. Anything to the 0 power, so x to the 0 power, you get 1. If it's a number to the 0 power, oh geez, hold on. I'm so sorry. Let me write that again. If it's a number to the 0 power, like, that's not a number, that's another x. Like 5 to the 0 power. 5 to the 0 power is also 1. The rule that I didn't share here, which I should have, is you can't have a negative exponent. So if you have a negative exponent like x to the -2, you flip it around. If it's in the top of a fraction, you put it into the bottom. Keep the exponent, but make it positive. It looks kind of weird because we don't have a fraction. So if you don't have a number in the top, no, it's a 1. Similar to that, if the exponent is negative in the bottom, let's put 2 over x to the -2. See how it's negative in the bottom? You bring it up to the top next to 2. And that becomes positive. All right. So negative exponents, you need to flip. If it's in the top, bring it to the bottom and make it positive. And if it's in the bottom, if the negative number or the negative exponent's in the bottom, bring it to the top, make it positive. I don't know if we're going to see that. I just want to talk about it because that's another rule. I'm sorry. All right. Let's go and look at the lesson. All right, here we are. I knew that was going to happen. Why can't I just use this the right way? All right. So number one asks us to evaluate. So when it asks us to evaluate, that means that they're going to give us a number. So they're going to give us a number for our variable. In this case, they're giving us that n is -6. So all you're going to be doing is you're going to be replacing n with -6. So you have 8. So you have 8 absolute value. Instead of n, you're writing -6 plus 3 absolute value. Now you're going to follow PEMDAS. Okay, so you're going to simplify what's inside of the square root first. I didn't mean square root. Inside of the absolute value first. So -6 plus 3 is -3. And the absolute value of -3 is +3. So once you take away the absolute value, I'm changing that to parentheses. Oh, geez. So once we find the absolute value of -3, which is +3, I'm going to put it into parentheses. So we took away the absolute value now. And then 8 times 3 is 24. You would do the same thing for question 2. In this case, you have z is 362. So you would put 7 plus 9 square root of, I didn't save enough space, I don't think. It's okay. 362 minus 1. I left my stylus in school, so I'm using my fingers. So 7 plus 9 times the square root. 362 minus 1 is 361. Now here we go. The reason I'm doing this is so I could show you how to do this in your calculators. So you're going to want to find the square root of 361, which is 19. So then you do multiplication. So hold on, let me go back here. So you have 7 plus 9. And since you figured out what the square root of 361 is, you're going to change that into parentheses just like you did with the absolute value and write 19. Now you have to remember your order of operations. So we didn't have parentheses. Well, I guess kind of with the square root. Now we have to do multiplication before we do addition. So you're going to do 9 times 19, which is 171, then add your 7. So you get that 178 there. And there's our answer. All right. So that's kind of the gist there. 3 is hard. 4 is very similar. I'm going to come back to 3 just because it's going to take the most time. Question 5. This looks like it would be hard, but all they're doing, I have to zoom in. You see how they both have the same exponent? We could just write it with one exponent. This is kind of like the power rule, the opposite of the power rule. So if you're looking over here, they're being divided, 5/6, and they both are to the 5th power, so you could rewrite it like b. Okay, so that one was easy. Number 6, completely, we're going to use our calculators. So we have the square root of 12 times 4 times the square root of 3. So remember, we have to put square roots in first. I'm going to put in the square root of 12 times the square root of 3 times 4. I think that should work. Let's have a look-see. I don't know if it will. Times square root of 3 times 4. Oh, it does. So you get 24. So remember, you have to put your square roots in there first. Okay, so 12 times the square root of 3 times 4. Okay, put your square roots in first, then you can multiply it by the number. Remember I told you you can't have a negative exponent, so if it's in the top, you put it down to the bottom. And instead of it being a negative exponent, you make it positive. And the placeholder 1 has to go up in the top, so D looks like that answer for us. We did a question like number 8. Number 9 is going to be one of those harder problems, so I'm going to come back to it. And number 10, kind of a calculator problem. You have the square root of 63 times 6. Minus, what is the other one? The square root of 28 times 5. Let's see if I can make it work like this. I don't think so. No, that's not going to work. So wait, what was the first one? The square root of 63 times 6. So that's 47.62. Let me write that down. $47.6. All right, and then I'm going to put 5 square root of 28 in. Our calculators at school will be so helpful for this right now. Is that times 5? All right, so did I do that? Square root of 28. Let me just make sure. I don't want to, because I couldn't read my handwriting. I think so. All right, 26.5. 26.5. Okay, and I'm going to subtract them. So 47.6 minus 26.5. So about 21.1 now. We're really estimating with these here. Let me change my color. So that's 21.1. So 21.1, I'm going to cross off 28 because remember from the square root lesson, it's only going to be as big as 21. And I'm also going to cross off 34 because 34 is bigger than 21 too. So I'm going to put this 11 square root of 7 in here. Remember, put the square root in this calculator first, which is 29, which is bigger than that 21. And the other option was 8 square root of 7. So let's put that in there. Remember 7, which is 21.1. Okay. I know not exactly, but close enough. All right. Now let me go back up to the harder problems and then I'm done. All right. For this problem here, you're going to want to work inside out. Okay, so you have one big parenthesis here, but inside of the parenthesis, you have an absolute value. Okay, so that's where you're going to start working. So everything else besides that, I'm changing. Or I'm keeping. So for right now, I'm copying down 5. I know that that's really, I didn't mean that, but parenthesis 13 minus, okay, now I have absolute value. I'm taking care of what's inside of this absolute value. So what I mean is I'm just doing what they tell me to do. What is negative 10 plus 5? That's what I'm doing. So negative 10 plus 5 is negative 5. Okay. That's all I'm doing on that part. Okay. Over here, it's a separate absolute value. So I could deal with that right now. So I have the absolute value of 12 minus 3, which is 9 to the second power. All right, let me zoom out here. Now, again, in this big parenthesis, I have a smaller absolute value inside, so I have to deal with that first before I could deal with the 13. In other words, again, I'm writing everything else. So I have 5, parenthesis, 13, minus. The absolute value of negative 5 is positive 5. So there goes the absolute value marks. Parenthesis. Okay, so I'm dealing with that separately from this one. Over here, I have the absolute value of 9, which is 9. So I brought down my minus sign, and I took away my absolute value bars, and I'm going to put the 2 back up as an exponent. Coming back over here. Again, this is what you're dealing with, the parentheses. So I have 5, parenthesis. 13 minus 5 is 8. Close it. Minus, bring it down. Oops. And then you have 9 to the second power. So you could deal with that right now because that has nothing to do with this parenthesis. So 9 to the second power is 81. All right. Over here, 5 times 8. Multiplying that, you get 40. Minus 81. And then, finally, you throw that in your brain or your calculator, and you get negative, 41, which is D. All right, that one was kind of hard. There it is if you need to look at it. All right, and then finally, I guess this is the one I need to look at. I'm going to erase this 21.1 because I need room for this. Oh, this is just evaluating. So this one's not bad. So everywhere you see an X, you're going to put negative 12, and everywhere you see a Y, you're going to put negative 14. So let me just rewrite that. So I have absolute value of 5, and instead of me just writing negative 12, I'm going to put a parenthesis around it because it's negative. But I also just would put a parenthesis around it even if it was a positive number. I just like to do that just in case. So instead of X, I have negative 12 now to the 4th power minus, let me move this over, 2 times Y, which is negative 14. Again, I'm going to put in that into parentheses. Absolute value. All right. All right, so we're working inside out. So we have 5 parentheses. So you have negative 12 to the 4th power. Admittedly, I don't know what that is. So I think what you would do is you would put parenthesis. Oh, does that come up? 12. You're going to keep it negative. Could I put this around? I guess I can't put the parentheses around. To the 4th power. So that's basically, instead of me fooling around, negative 12 times negative 12 times negative 12 times negative 12. So that's 20,736. 20,000. Wow. 736. So this is going to be a pretty big number here. Over here, we have minus 2 times 14. So minus 2 times minus 14, which is positive 28. So plus 28. All right. More calculator stuff. You have 5 times 20,736. And then plus that 28, which is 103,708. It's the absolute value of it, so it's just the positive form, and it already is positive, which is A. Did I copy that? No. Doesn't matter with me. Did I do that wrong? I must have done something wrong. Oh, there it is. I'm sorry, it's B. Oh, jeez. All right, that's it for simplifying it.